Dr. Andrew Steckel is an engineer, but his work over the last decade has found himself working more with medicine. Here in his lab at UC's College of Engineering and Applied Science, Steckel and his team are combining materials that don't have much in common. In this demonstration, they're combining Teflon and polycarbonate, or PCL, the pink stuff. The two materials combine when they add electricity to the drip.
It's a bit of complicated physics, but bottom line is that when you combine the forces of the electric field plus the viscous forces of the fluid, you form a very fine jet, a liquid jet. And this jet is stable for a bit, and then it becomes unstable and starts to spin around, hence electrospinning.
If you look closely, you can see below the nozzle that it appears the liquid is spraying, but it's actually spinning.
What we have focused on in this part of electrospinning is what we call coaxial electrospinning. What this means is that it's actually a fiber within a fiber.
On this foil-type plate, a new material is forming. It's micrometers thick, and if you watch, the water droplets slide right off. The new material could be used to protect clothes or other items if it could be mass-produced. A big challenge in this field because of costs. Electrospinning has been around for nearly 120 years, but only recently have advancements in the field opened a big door to more possibilities.
You can then combine materials that normally, whose properties don't normally exist in a single material in nature. So that's the big advance, I think, in this particular field.
One big advance is creating new materials that could treat brain tumors or provide a new form of contraception.
A lot of our recent work has been for medical applications where we're looking to control the release profile of these drug molecules and furthermore to combine multiple drug molecules into one material.
The electrical engineering team at UC has been working with medical researchers at Johns Hopkins University to develop a localized treatment for glioblastoma. It could potentially reduce the amount of chemotherapy a person would need for treatment.
You can have, for example, from the outer layer, a painkiller type molecule that is released to give you an immediate boost, make the pain go away, and then from the core on a much slower basis, a second material that is basically of a therapeutic nature.
Dr. Steckel says animal trials of the treatment have been showing promise, and also by finding ways to electrospin drug molecules, they could cut down on the number of pills a person takes on a daily basis for a variety of medical conditions. At the University of Cincinnati, Rod Hissung, Spectrum News.